If they all go off, we all go down. That's the doomsday scenario that some people believe is going to happen when it comes to nuclear war. If even just 2 nuclear bombs were to detonate, then we could all be wiped out by the massive blast radius and the fallout alone. But what if more than 2 bombs were to go off? Let's find out in today's episode of What If. We all know about the atomic bombs that devastated Hiroshima and Nagasaki during World War II. These weapons of mass destruction were the first and only times that these types of weapons have ever been used in an actual war. It's hard to imagine the devastation that must have occurred at the time, not only from the bombs themselves, but also afterwards with radiation poisoning taking many lives long after the initial explosions. But what if several of these atomic bombs were to go off simultaneously? In total, 6 nuclear bombs were dropped over Japan during World War II. 3 were dropped on Hiroshima, and 3 were dropped on Nagasaki. The bombings of these cities caused tens of thousands of deaths, most of them being civilians. This is the reason why so many people are against nuclear weapons to this very day. They are indiscriminate killing machines that don't care whether or not you're a soldier or a civilian. So now let's increase the stakes. What if 12 bombs went off? If you take the 3 bombs that were dropped on Hiroshima and add another 3 to it, then you get a total of 6. And if you take the 3 bombs that were dropped on Nagasaki and add another 3 to it, you get a total of 6. And if you take the 3 bombs that were dropped on Hiroshima and add another 3 to it, then you get a total of 9. And if you take the 3 bombs that were dropped on Nagasaki and add another 3 to it, then you get a total of 9. To understand what would happen if 12 of these bombs were to go off simultaneously, we need to understand what happened to the cities of Hiroshima and Nagasaki when the bombs were dropped during World War II. Both Hiroshima and Nagasaki were primarily military bases for the Japanese army. So when the United States dropped the first atomic bomb on Hiroshima, a lot of soldiers were caught off guard. The bomb exploded 500 feet above the ground, and it was estimated that about 80,000 people died immediately from the explosion and the intense heat. Most of the city was completely leveled by the impact, and those who survived the initial explosion faced other dangers, such as broken glass, collapsed buildings, and fires raging throughout the city. Even the soil beneath the city had become radioactive and contaminated. The second bomb was dropped 3 days later on Nagasaki. Again, tens of thousands of people died right away, and once again most of the city was destroyed. Both cities suffered greatly in terms of the loss of life and the amount of damage that was done to their infrastructure. This was the first and only time that these types of weapons have ever been used in warfare. And thankfully, it was enough to end the war and bring the United States and its allies to victory. But what would happen if instead of 2 separate bombs going off, they all went off at the exact same time? If all 6 of the bombs that were dropped on both Hiroshima and Nagasaki went off at once, then the blast radius from each individual bomb would be affected. There's something called the Rule of 40. Basically, if you double the distance away from the epicenter of a bomb, then the intensity of the blast wave will be reduced by 20. For example, if there was a bomb dropped in the middle of a city and it had a blast radius of 6 miles, then doubling the distance away from the epicenter would mean that you'd be 12 miles away and the blast wave would only be 20 less intense. So it would still be pretty dangerous. But the further you get away from the epicenter, the safer you'll be. In the case of having 6 bombs go off at once, then the blast radius of each bomb would be affected by all the other bombs that are going off around it. This means that the epicenter of any one bomb wouldn't be solely dependent upon how far away you are from it, but also how far away you are from all the other bombs. In other words, if you're close to any one bomb, then you won't be safe, because you're also close to all the other bombs. But if you're far enough away from all the bombs, then you might be able to survive. Now that's assuming that the bombs are going off in a place where there's nothing else around it. We're talking about the ideal situation where there's no buildings or mountains nearby that could affect the blast radius. All the air pressure waves from each individual bomb would combine, and the overall blast radius would depend on things like the size of the bombs themselves, the altitude at which they explode, and the atmospheric conditions at the time. Let's say that all 6 bombs explode at the same time and they're all at ground level. Then the blast radius would probably be around 18 miles from the center of any one bomb. This means that if you're anywhere within that 18-mile radius, then you're probably not going to make it. The blast radius would be strong enough to level everything in its path, including large buildings, trees, and anything else that's in the way. Even if you were outside of that 18-mile blast radius, you'd still be in danger. The shockwave from the explosion could travel up to 100 miles away from the epicenter and cause some serious damage, and that's before the nuclear winter even begins. All 6 bombs exploding at once would release massive amounts of radioactive material into the atmosphere. This would create a massive cloud of smoke and debris that would block out the sun and cause temperatures to plummet worldwide. Depending on how high up the bombs exploded and the strength of each individual bomb, the radioactive fallout could reach hundreds of miles away from the epicenter. But what if instead of the bombs being at ground level, they were all in the air at a high altitude? Well, it depends on how high up in the air the bombs were released. If they were all at the same altitude and high enough up, then the blast radius could potentially be much larger than if they were at ground level. This is because the air pressure waves would have more room to expand without being obstructed by buildings, trees, or other objects. However, if the bombs were too high up in the atmosphere, then the blast radius could actually be reduced. This is because the air pressure waves would have less air to travel through, and they would dissipate more quickly. It's also worth noting that the altitude at which the bombs were released would affect the amount of radioactive fallout. If the bombs were released high up in the atmosphere, then the fallout would be much more widespread as the bombs would have more time to spread out before detonating. The height at which the bombs exploded would also play a role in determining the amount of thermal radiation that reached the ground. Thermal radiation is the heat that's emitted from the bomb as it detonates. If the bombs exploded high up in the air, then the thermal radiation would have more time to spread out before reaching the ground, which would reduce the amount of heat that reached any one particular area. All of these factors would have to be taken into account when trying to determine the blast radius and the amount of radioactive fallout if all 6 bombs were to go off simultaneously. It would be a complex calculation that would require the expertise of many scientists. And it's not just the blast radius and the radioactive fallout that would be affected if the bombs were dropped in different ways. The amount of damage caused by the bombs would also depend on things like the time of day, the weather conditions, and the proximity to other nuclear reactors. If the bombs were dropped at night, then the thermal radiation from the bombs would cause massive fires as the heat ignited buildings and other structures. If the bombs were dropped during the day, then the thermal radiation would cause severe burns to anyone who was caught outside. Weather conditions would also play a role in the amount of damage caused by the bombs. If the bombs were dropped on a day with high winds, then the radioactive fallout would be spread out over a much larger area. If the bombs were dropped on a day with no wind, then the radioactive fallout would be concentrated in one area. Finally, the proximity to other nuclear reactors would also play a role in the amount of damage caused by the bombs. If the bombs were dropped near a nuclear reactor, then the blast radius of the bombs could cause the reactor to melt down and release even more radioactive material into the environment. All of these factors would have to be taken into account if we were ever to try to determine what would happen if all 6 bombs were dropped at once. It would be a complex calculation that would require the expertise of many scientists, and hopefully none of us will ever have to find out the answer to this question. Thanks for watching.